I wanted to have some fun with you this morning and start digging right into some engineering stuff. A lot of my time over the last couple years has been building out this project as a starter kit for, we're going to do a lot of typing today, a starter kit for building services in Go, not a framework. There's some great frameworks out there, but I really want everybody to be able to engineer the products that they're building for the constraints and the things that you have. So what I want to talk about today is we're going to do some coding. We're going to start trying to put some mental models around this code base. I want to talk about the things that I'm seeing that are lacking on development teams when I'm walking into some consulting engagements, and we'll see how much code we can write. But at the end of the day, this is out there, and it's really if I were to start a web service today for a company, this is where I would start. Okay, so another thing real quick. If you're feeling overwhelmed as a software developer, you should. We are being asked to know way too much. Look, you got to have a micro level understanding of code today, right? You've got to be able to understand almost at a line of code, what are the trade-offs of every decision? What are the costs that you make? I can spend 3 days talking about data semantics alone at a micro level. Then you got to have a macro level understanding of code, which is some of that stuff we're going to talk about today. Design, architecture, logging, config, startup, shutdown, the whole 9 yards. You got to have all of that. Then you got to understand your production environments today because you're now responsible for deploying all of your code. So now you got to understand how to install Kubernetes and everything that goes along with that. And if that wasn't overwhelming enough, now you've got to be able to see what's happening in production. So now you've got to become an observability expert. Right? And you got to start figuring out how to get metrics and Grafana and Prometheus and whatever else you want to use. And if that wasn't enough, you got to completely understand your business, because if you don't, how are you going to build anything you're supposed to build? So if you're feeling overwhelmed, yeah, you should, because 30 years ago, I didn't have to have all of that knowledge. I'm happy I'm 50 and I'm about to retire in 5 years, okay? Trust me. So let's jump into it a little bit here. What I'm going to do literally is we're going to just see how much code we can write over the next 40 minutes, and we're really going to start from scratch. And I want to just have some basic engineering conversations with you around design philosophy and guidelines. You do not have to agree with everything I'm saying. In fact, if you did, it would be boring, okay? And one other thing before we start. I get to live in utopia, all right? I don't have any constraints other than the ones I put on myself. You have constraints at work. So some of the things that I might be sharing, you might be like, Bill, I can't do that. And that's totally fair. So you've got to take a little bit of the design philosophies and guidelines I'm sharing, work them around, work them out for what you want. All I care about is not so much you agree with me, but you have your own design philosophies and guidelines. What do you believe? And I'd love to have those conversations with you throughout the day, because I learn every time somebody shares something that's important to them. Now, one of the big things that's important to me if I'm going to build a service for production is I focus on my ability to debug and manage this code base from day one. To me, that is one of the most important things you have to have. You can jump in and start building your business logic, but if you can't already start to identify those bugs, fix those bugs, deal with those, you're just not going to be as productive as you otherwise could be. So that's really where we're going to be starting today. Now, thanks to modules, I'm going to start working outside of my Go path already. This is going to be cool. So we're going to set up some project structure that I use. We'll set up some modules. We'll start writing some code. We'll see how far we get. So I'm just in this code folder. This is not my Go path here. And what I'm going to do right away is just make a directory. We'll call it our service directory. And we'll just jump into code right away from here. All right, so this is pretty cool. Now, what I tend to do with a service right away is I create a couple of folders right at the root. I create a command folder, and I create an internal folder. Now, I like the idea of internal folders, especially if this is a product, because we get some special compiler protections from people trying to import packages that they shouldn't. And I really think the internal folder for your projects is really important. Because the last thing you want is some project that's not your own trying to import packages they shouldn't be importing. So that internal's really nice there. And that's where we're going to put our business logic or any foundational logic we have. Command is where we're going to be building our application code. And for me, this is like presentation layer stuff for a service. So request, response, data validation, calling into the business layer. So what we're going to do is add a folder under command. We're going to call it the sales API because that's what we're going to be building. And I'm going to add a main.go immediately right in there. And another thing I do here is I add another internal folder for any other packages that I'm going to have in there. I like really protecting all of the code in here. Again, you don't have to agree with everything I'm saying here. I'm just sharing some of the things that we're doing here at Arden and what I'm doing. Okay, so we've got our main.go. We're going to be ready to start writing some code. But I've learned already that a good place to start before I even do anything is modules right now. So I want to init my modules right now so we can just start making sure that as we bring in some third-party stuff, the project's going to support that. Now, I'm outside of my Go path here, so what we're going to do, at least at this point, Go mod, I should say, Go mod init, is I'm going to tell mod what the name of this module is, because at the end of the day, even though this is a project, it's still also a module. So I'm going to pretend right now that this module here, this project that we're building, is going to be at github.com ardenlabs/service. And now we've got our mod file right here, and this is going to be basically the root of this project, and I'm going to assume this is where we're going to be putting it in GitHub as well. So we've got our project structures in place, we've got our modules ready to go for any dependencies we're going to be working with, and we're going to start now thinking about our initial entry point. So obviously this is going to be package main. Now, one of the things I'm going to do to help speed up a little bit is just start copying some code, little pieces. We're going to talk about that. I'm going to give you the design philosophies of what we're doing in this project, and then you can think about some of the things that you're doing in yours. All right, let me just take a little bit of this code right here to start, and we'll talk a little bit about what I'm doing right in here. Now, for me, we're going to have our main, right? So there it is right there. And you've noticed I've got an unexported function named run. And right there in main, we're handling that log and we're handling that OS exit in one place. So the idea here is I used to put a lot of code in main, but it got to a point where I really wanted to have that singularity on that log and that OS exit. So the idea here was keep main real simple with just those two lines of code you see on 10 and 11, and we'll do the bulk of the work for startup and shutdown in run, because then we can use that idiomatic error handling in Go to just return that error back and handle it in one place. So that's kind of what we're doing right there. Now, I like very long run functions. I don't like on startup and shutdown breaking it up too much. I can use closures for Go routines. I can do other things. And the very first thing that we're going to need to focus on, in fact, one of the biggest mistakes I see when I walk into a shop is this question right here. And I love asking this question to all the developers, so I want you to think about this. For the products that you're building right now, for the services and tooling that you're building, what is the purpose of your logs? Logging is so important. It's the kind of UI to everything you're doing if there's going to be problems. And so for me, this is one of the core questions you have to ask before you even write a line of code. If you don't understand the purpose of your logs, you're going to have a mess. Think about it right now. If you've been in any of my classes, you hear me say this all the time. All right? Debuggers don't find bugs. They just run them in slow motion. And you can't attach a debugger to your production environment. It ain't going to work. And so when you allow the debugger to become a crutch while you're doing development, what are you going to do when that production bug hits? You're not going to be able to manage it. I used to manage, I tell this story. For 20 years, I managed development teams, and nobody was allowed to turn a debugger on without my permission. They just weren't. Because I knew at the end of the day, if the logs and anything else they had at their desk wasn't working for them during development, it wasn't going to work for them during production. Now, they got stuck for 20 minutes, that's fine. We'll turn it on, but we got a bigger problem at that point. So your mental models of the code base, your logging and your metrics or whatever it is you're using has to work at development. So what is the purpose of your logs? Now, I get to live in utopia. So the purpose of my logs is for debugging the app. That's it. I'm not going to put any data in those logs. I'm not going to be sending it off to Elasticsearch or anything like that. So I can have human readable logs. I go crazy when I see on Twitter, if you're not using structured logging, you're doing it wrong. Whoa, slow down. Every environment is different. Everybody's purpose is different. You got to do what's best for you and the engineering that you have to do. So I don't need structured logging right now. In fact, because of that, I can use the logger from the standard library. I love the logger from the standard library. It's nice and simple. And that's exactly what we're going to do. So the purpose of our logs right now is just to help us debug problems in this service. I don't need anything more or less than that. So what I'm going to do is bring in, as the very first thing that we do, our logger here. Now, everybody can still see that. Okay. So if you notice, however, I'm not using that singleton in the logging package. That will be a very big mistake. A core philosophy of mine, it's really a base philosophy that drives everything else, is do not make things easy to do. Make things easy to understand. This, to me, is a critical philosophy because it's not about the time you're spending at your desk at 2 in the afternoon when life is good. That time is easy. You need to focus on the time when that bug is hitting production and everybody's on top of you, and you need to fix it. You need to fix it with the minimal amount of disruption to the code base. That's when all of this becomes important. And so if you're making things easy to do in the idea that you're going to be more productive day in and day out, you're going to hurt yourself when that bug comes in. This has been my experience. So we got to focus on making things easy to understand. And easy to understand means we're going to write APIs maybe that take a little bit more parameters than you're used to. We're going to be much more precise in the things we do. And everything from startup gets passed through the application. That way nothing is hidden. It's going to help you with testing. It's going to help you with debugging. It's going to help you with a tremendous amount. And you're going to be like, Bill, but this is tedious. Yeah, it is tedious. But now's the time to be tedious because when the bug hits, you're going to thank yourself for doing these things. All right, so we've got our logger. We can write human readable logs. We don't have to do much there. And we're going to create our own logger. We're not going to use the logger as part of the standard library, that singleton that's out there. We're going to pass this logger around anywhere we need. And now we know what the purpose of our logs are. Now, the next big thing that you have to understand after you know what you're going to do with logging is configuration. Configuration is a big one. Well, we could sit and spend 2 hours just talking about configuration. I mean, basic questions like, am I able to restart the service if configuration changes, or do I have to worry about changing config while it's running? Right? I mean, I want to keep it simple. I'd love the ability to be able to stop and start if configuration changes. It's, I think, one of the nice things that Kubernetes is giving us in those orchestration systems. But I've been in environments, maybe you're building an ingress server or something, like you can't shut that down if something changes. And now things get complicated because if you're doing all that too, now the next question is, what do you want to do for configuration? You want to use files? What kind of file do you want? And if you're using files, how do you distribute that file across your production environment in some particular way that it all sets up? Right now you're starting to build GUI tooling and other tooling just to get files pushed around, right? Can we use environmental variables? What's up with that? I like using environmental variables, but now we got secrets. We could sit here all day and talk about all the trade-offs with every decision you have to make with configuration. But I'm somebody who likes to keep it simple until we can't. So we could just use right now some basic environmental variables. But let's talk about code for a second because there's bigger problems. I can't tell you how many times in my career somebody's come over to me and say, Bill, what are all the configuration options for this service? And I'll be like, I don't know, give me a second. I have to go through the code. Because we allow every piece of code to hit configuration when they want, where they want, and now suddenly developers are throwing little pieces of configuration throughout the entire code base, and nobody has a real clear picture of what can and can't be changed. This has to stop. I've also had problems in environments where you set defaults up for things, and for whatever reason, the production environment can't use those defaults. And now you have some operator who's your friend asking you, well, I need to override this, and you're like, I don't know. And then you start getting into fights with friends because, right, they're frustrated because they can't get things in production, and you're frustrated because you can't help. So all of that has to end. And there's ways to do that right away in the code. So let's start setting up for at least success in those areas here. And since we're going to be just focusing on a service right now, we could just pull in a little bit of configuration. And one of the things I like doing is when we set up our config structs, to make sure they are not named. I don't want to be passing a config struct of some type throughout the app. I want to send the information around config down into the app because I can stop and start this service. And so by not naming these structs here, this particular struct, I'm really forced to have to send those individual values to whatever APIs that I'm using. Now, if you see what I've done here, I've got this config type, or this struct, I've got this web struct with certain fields that we're going to need right now, and then I'm using a tagging system. So we built a config package, worked with Andy Walker on it, to do 3 things, which I think are really, really important for a service. 1, allows you to set defaults. I don't believe a service should crash because some value is missing. Now, these defaults should most definitely work in your development environment, and that's going to help bringing on new developers, and anybody has to come in and do something, get up and running very quickly. The more that these defaults can work in your other environments, it's even better because that's less configuration that you have to even worry about setting. So we've got some defaults right here that we'll use, but you've got to be able to override the defaults. And so we're going to do 2 things to allow these defaults to get overwritten. 1, we're going to support the ability to have environmental variables based on the structure of this struct, and we're going to have command line flags. So our friend who's working operation can also, at the command line, override anything here, and we're going to have a little bit of help. So if somebody wants to know what all the configuration options are, well, guess what? -- help, and it's all there. But if somebody comes to me and says, Bill, what's all the configuration for the service? I only have to go to line 26 in main, and we're good. So if I'm doing a code review and anybody other than this source code file imports the config package, code review stops. You're not allowed to do that. It has to start here. So what I'm going to be doing is, this is our basic config right now. I'm going to pull in the code that we're going to be using to parse this stuff out using that third-party package that we wrote. So I'm going to save this, and what you're going to see right now is thanks to all the great tooling we have in Go using VS Code here and the Go Please server, some of the things are already in my module cache. You can see that, boom, it's already found the imports for the Arden Labs conf package, and I like using Dave Cheney's errors package. I'm still using it. And you can see that those imports came in for me automatically. So very cool stuff. And we've just got a little bit of code here that is parsing everything out. So you can see that we're just using our pointer semantics, we're sharing it, and now what's going to happen is we're going to get those defaults. If there's any environmental variables, they will get overwritten, and then if there's any command line flags, that will get overwritten. If they're asking for help, we'll display it, and then we're set. And we can actually already kind of watch this work, right? We can already do that. I mean, I'm not using that logger just yet. We should be okay here. Let's see, we'll move into this folder. We should be able to already look at help. Wrong one. Copy path. So let's come in here. Should be able to build this. We're missing something? I love pair programming. And that's not even, oh, do I have network issues there? Shoot. All right, well, oh, I didn't even bring in the modules yet. All right. Well, I have syntax errors, don't I? All right, let's keep going. Well, it doesn't know this, it doesn't know that. I'm missing the return. There we go. We're going to fix this right away. It would help to have a return here, wouldn't it? So let's do that. All right, so I'm going to have networking issues here today. So let's just keep going while that's happening. So if we can get this thing built, we should be able to do the -- help, and then we'll be able to see some help there. Okay, cool. So we now have our config in place. We're able to have these defaults. We're able to replace all of that. And again, everything I'm focusing on right now is about being able to manage and debug this application. Okay, so now that we have this, what's the next thing that I'm going to want to do? Well, the next thing is this problem. I can't tell you how many times this has happened to me. How many times have you made a code change, merged that into GitHub, went to go look at it because your CI server built it and put it out there, and that fix you just made didn't work? So you go back to your desk and you write a little bit more code, and you go through this whole process for an hour, and finally you say to yourself, I don't think I'm running that code that I just changed. How many times has that happened to you? Yeah, right? And then you get into a fight because the ops side is telling you, no, we've built it, there it is. And you're going, no, it's not. That has to stop too. So one of the things that we can do, even when we're building code here, is the following. So what I'm going to do is a couple things. When this application starts up, we're going to have to log at least a couple of things here out of the box. So one, we're going to want to log the config that we're using, because if we override anything in that config struct, we're going to want to log that. So we're doing that on line 61 and 65. However, how many times did you log your config and put something in the logs you shouldn't have? Oh, right? All usernames, passwords, keys. Yeah, we can't have that happening either. So one thing that we've done with the config package to help with that is we've got tags here. So you could say things like hidden, don't print this in the logs when you're about to display what's going on here. Really important stuff. And that's why if you're not using your logs during development and you're not checking it, these things end up slipping. So we've got tags in here as well that will say, okay, when we do display this, this is not something we want to put in the logs. But even more important than that, you might see here two things that I'm doing. I've got this variable named build that this code doesn't know about yet. Let's bring that variable in. Now, a couple things about package level variables around the philosophies that I have. We really want to avoid package level variables, but I have one rule that allows us to use them in code. You can use a variable like this if, one, initialization doesn't matter. In other words, as long as it can be initialized in any order before main, you're good. And two, the only source code file that's allowed to touch this variable is the one that it's declared in. So if we can follow those two rules, then I will accept something like that. Other than that, no. Because again, this is going to hurt on initialization, on testing, on everything else. It's hidden. But I know it's only going to be used here. Now, if you notice this variable, it says develop. So what we're going to do, and what the Go build tool does with the LD flags, is it lets us set this variable at build time. Now that's kind of cool, because if we could set this at build time, that means that we could pull Git information, like maybe a commit ID or a date, which then gets embedded into the binary. And if that's the case, then all we have to do every time we start that server after a code change is what? Look to see what we're actually running. And to do something like that, let's see, we look at the core service here. To do something like that on the build side, if I can remember where all that is. No, it's not going to be there. It's going to be here. Right here. So just by applying these LD flags on the Go build, if you're in say, in your folder in the repo, we could just pull that VCS reference. It's going to go right into that main variable, main.build, and now every time we start that service, I can guarantee that we're using the code that I've changed. No more problems, no more fights, no more issues. Yeah? Bigger? All right. All right. Cool stuff. Okay, so what we're going to be doing here is two things. Now that I've got the build variable there, we're going to log that. like you see on line 61. But if you notice, I'm also using the xpvar package. I really love this package. This package is going to give us metrics right out of the box, and the leading providers that give you all those UIs already support this format. So the other thing we can do immediately day one is set up some metrics in our server and not have to worry about what third-party system we're using. We can get all of our metrics here locally. So we're going to put that build information as well in the metrics. So if we bring up our little dashboard, we'll also know immediately what version of code we're building. Everything I'm doing right now is to help set ourselves up so we're in a position to be able to manage and debug this code base before we start doing any real work. Okay, so we've got our logging figured out. We've got some configuration figured out thanks to a third-party package. We've got our ability to know what we're actually running in terms of the build and any overrides that we've done from there. What's the next thing that we really need to focus on? The next thing for me is our debug service. And that's really the very next thing that I want to put into what we're building here. Now, what's really cool is Go is giving us all of this support already out of the box. So look at what we're doing right here. At this point, I'm launching a Go routine that's going to be binding the default server mux, against a port. Now, since I'm having trouble building this, all right, let's see if we can build it. Brilliant. So now that it's building, let's do this. I have something on the network. So, there we go. So here's that help that we got thanks to that config package that we built. And right now, any operator can come in and just see what the flags and the environmental variables are right there. You know everything that you can do, and you can see the defaults. Okay, cool. So we have that. Great. Now, we come in here, and we're going to bind this Go routine to the listen and serve port right there on the default server mux. Now, there's two cool things we're going to get by doing that. One, I'm going to add this import right out of the box. Here it is. And what this import is going to do is bind a route to the default server mux for debug pprof. Now I have all of my CPU, I've got my memory profiling information, I've got tracing information, I'm going to show you that in a second. And I've already added xpvar, which also adds a debug/vars route to the default server mux. So watch what we can do right now. Now that we're binding just that, I think we're binding it on port 4000, yep. Let's just add like a select statement here to just hold the server. We should be able to build this. And now that it's built, we should be able to do a couple things. All right, this is up and running. There it is. We can see our output. We can see the config that we're using. We can see we're in develop mode right here on 4000. I can come over here now. Localhost 4000, debug, pprof, boom. So right out of the box. Think about what I'm doing right now. I don't care about the business problem just yet. I'm not ready for it. Think about what I'm doing. I'm setting myself up for success with all of the goodness and the tooling that Go's already given us. Right now, I can get memory profiles. I can get CPU profiles. I can get tracing information. If you've never seen a raw memory, we haven't run anything through here yet, so it doesn't look that fancy. But we can pull all of this stuff right in. But this, to me, is also really, really important. Because it goes back to the idea of what is the purpose of your logs. I don't like putting data in my logs to the extent that I can prevent it. I now have a debug vars URL. A debug vars URL. I have metrics right now. Now, I don't want to read it like this. So here's something that's really cool. A long time ago, somebody built a console-based tool called xpvarmon. Oh, hold on. I have metrics right now at my desk, and it doesn't matter what my company or ops team has decided. I can be on the airplane right now, looking at metrics, looking at logs, and I'm all set up right then and there. This tool has been in the ecosystem for over 5 years. xpvar is a package that's been there forever. We have all of this goodness. You just got to wire it in. And then at this point, where you could start doing some development, you're ready to go. So, cool stuff though, isn't it? Yeah. And what's nice is all like Datadog and all the leading metrics providers already support this format. So you could just have them even plug right into that URL you exposed, and you're done. So this is really cool stuff. All right. So we've got our logging, we've got our config, we've got our metrics now, so we don't have to pollute our logs with data. We can just start dealing with metrics. You can see the build dev there. We know what build we're actually using. Okay, great. So what's next now that we're in our ability to be able to debug some of that? Okay, the next part is actually now binding a route for the actual web APIs that we're going to need to expose for our business problem. And the big thing that we're going to want to do is have the ability to load shed on shutdown. I mean, you can't be issuing a kill 9 every time you want to restart your service somewhere, right? You've got to have a controlled shutdown. And so what's nice is the HTTP package supports the ability to do load shedding on shutdown. We got to just set it up right. So let's get ourselves going to a point right now where we can do a controlled shutdown, and then we'll figure out with the time we have what sort of mux maybe we want to use. So I'm going to pull in a little bit of this code here, and we'll start talking about it. All right. So the first thing I'm doing is I've got my signal channel of a buffer of 1, and we're binding it to the notify API so we could start getting our control C while we're at our desk or OS interrupt, or if you're in your orchestration systems, you can get your sig term, and that will signal us to do some shutdown. And then we're constructing that server value, and I'm just going to comment that out right now because we don't have a router just yet. We don't need it for what we're doing. So we're going to construct a server value. Now, if you noticed with the debug Go routine, I'm not worrying about shutting down cleanly in a sense. If you go to my classes, you always hear me say, you're not allowed to create a Go routine unless you know when and how it's going to terminate. But you also hear me say there's exceptions to everything. And this is a particular Go routine that I'm not going to spend a lot of time trying to shut down cleanly because ideally it's only really running when we've got problems. So I can keep that code clean, but this code that's going to be handling our actual business routes, no. This is one we have to do right. So we're going to construct that server value. There it is. We've got our timeouts. You see your timeouts there? I was working at a company one day, and a developer came over to me, and they were like, Bill, how do you know what those timeouts are supposed to be? And I started to laugh. I said, I have no idea what those timeouts are supposed to be. I don't think anybody knows what those timeouts are supposed to be. I just know I need them, so we put them in early. And if we get lucky enough, we'll spend some time to figure out what they are. So if you're in that boat, we're all together, okay? But you need timeouts because nothing's allowed to run forever. So you got to lay those timeouts in early, but don't like panic that you don't sure what they are. I usually use a number that's large enough where it's not going to get in my way. But at some point, you do have to come back and figure out what those numbers should be. Okay, great. If you also notice, we're using our config struct here to set all of these things up. And if you notice, I've got this really long run function that's happening. I really like that for startup. Okay, so we've got our server value. What's the next thing right here? All right, so the next thing that we're bringing in, now that we have our server value, is these lines of code here. So I'm adding another channel for our server errors, and then I'm launching a Go routine like we did before for the listen and serve call, but this time it's a method against that server value that we have. And if it fails, then it will signal that error across that channel. Okay. So now I've got a second Go routine listening on whatever new mux and port. In this case, it's going to be 3000. But we're not done yet on the shutdown. We've got to set up our shutdown code. And we're going to do that with this remaining code right here. So let's walk through what we have right here. Now, we're using a select case, which is going to cause this server, at least the main Go routine, to now hold the server steady. Before, you saw me using an empty select, right, just to hold the server. Now, we're basically using select again, but we've got our two channel signals that we're listening on here. We've got the server error, if anything happens to our actual service that we're listening on. And then we've got the shutdown channel. And ideally, this is where we want to be. If we hit Control-C, if we sig, we want to go to the shutdown. So let's take a look at a little bit of how this code works, because when I first implemented this load shedding with the API, I did it completely wrong. And I'll tell you where I made my mistake. So let's say we hit Control-C on this server. We get to the context, so we're going to create a timeout, whatever that is, based on the configuration. And then we call API shutdown. Now, the mistake that I made early on in this type of code was I thought that the API shutdown call returned immediately, and this listen and serve would hold until all the load was shedded. But actually, it was the complete opposite. As soon as I call shutdown, listen and serve is going to return immediately. It's just going to go down. We're done. The load hasn't been shed yet. The load is being shed while we block on line 130 on the shutdown call. This was a big mistake I made early on working with these APIs. Now, since I know listen and serve is going to quit immediately while we're holding on line 130, and it's shut down, but your code should be clean anyway. It's one of the reasons why I'm using a buffer channel of 1 right there in line 109. And I know we're shutting down and it's not going to leak forever, but we should be doing things cleanly. So we're going to use that buffer channel 1 just to allow that Go routine to shut down cleanly. And now we're holding strong on line 130 for at least the timeout. And if the timeout wasn't enough, we'll call API close, and then we'll log what's going on. So we actually right now are in a position to have a server that can start and shut down cleanly. And one of the things you really should do, especially early on in a service, let's see if we got that working. Come up and running. One of the things that you should really do early on is the following. However, you never do this on a Friday. Don't ever do this on a Friday because you're asking for trouble and you're going to have a bad weekend. Anytime you touch main or anything that could potentially be a problem with startup and shutdown, you are to go through this cycle. And early on in a service for the first couple of months, you almost want to do this daily, except on Friday. Turn the server on, signal it, turn it off. Turn the server on, run some load through it, let it finish, signal, turn it off. Turn it on, run load through it while load is going through it, hit Control-C, shut it down. If you do this on a regular cadence, especially early on, you will find those early data races, and you'll be able to fix them. If you wait a month to do this, it's going to happen, and it's going to be incredibly difficult to figure out what you did that's causing this data race to not let that server shut down. So this is, now, trust me, every time you go through this exercise, your stomach's going to hurt, because you know it's not going to shut down, and you're going to have to deal with it. And that's why you want to do this on a very tight, regular cadence. Very tight, regular cadence. All right. We got at least another 5 minutes here. So let's just at least try to get something bound really quickly in a route here. So if we come back to the code real quick, what we're going to see is that I commented out, here it is, I commented out our handler here. And this handler is looking for any router that implements that handler interface, right? It has that serve method. And what we're going to need to do is a couple things here. I want you to look at the API that I've written here. In fact, what we'll do is come back to the original service code for the little bit of time that we have left. If you look on 207, think about where we are right now in this code in terms of code path. At this point, the main Go routine is held, holding main here so the server doesn't shut down. And I've got two other Go routines, one that's for the debugging services that we're doing, and now we've got one for our actual API. Code paths have kind of seemed to have split off here. But the main code path now is what's happening on line 207, binding the router to that Go routine. So everything now, from this code's perspective, is going to flow into the router. And if you notice on 207, we're passing the things that this now code path needs. Again, to not hide what's going on. Make things easy to understand. Do not make things easy to do. Now, if you notice something, I'm passing the logger, in this particular case, authentication and database, but let's just talk about the shutdown for a second. I am passing a channel that we've called shutdown. Why? Because there may be situations in this server where we have an integrity issue. What if we identify an integrity issue that suggests that we should shut this thing down? We can't just call OS exit either. We still would like the ability to load shed if we want. So one of the ideas here is to take that shutdown channel and pass it into, in this case, our application layer. So if we do find a situation, we can internally signal a shutdown. Now this gets really interesting, actually, because now we can start having conversations about, well, who's actually allowed to shut down a server, right? And I would argue that, honestly, only the application layer is allowed to physically do it. But I think it's okay for packages to suggest that life is bad and maybe we should shut this thing down. Not literally be able to do it, but have the ability to say, I think there's a problem here, and I think you should consider shutting this down. Now, one of the ways that we do that in this code is by leveraging Go's error handling. And I want to show you just this last piece here. It's an important piece of infrastructure. When I think about error handling in Go, I think of the error interface as it relates to every function that returns it, more as a pipeline. A pipeline that's not going down the call stack, but a pipeline that's going up the call stack. And if you think of this as a pipeline, then think about it, because we always say that, well, errors in Go are just values, so they can be anything they want to be. Well, then that means that that error value can be a signal back up the call stack about something that potentially needs to be done. And if you think about it that way, then we could create a type like shutdown that now implements the error interface that we can construct and validate is a shutdown. And now any piece of code at the business layer, if it feels like there's a problem, could now pipeline this shutdown error back up through the call stack, where the web framework or the application layer can then go, oh, somebody wants me to shut down. What should we do? So it's not the code just going, slamming the hammer down. It's then sending a signal back up. We only ever think about signals with channels, and channels are providing signals. But I like the concept of signaling with the error interface as well, going back up the call stack. And then it allows you to really kind of be creative with error values to signal certain events that only your application layer can handle. All right, so all of this code that we've been sharing today, these ideas of focusing on making things easy to understand, not easy to do, and all of these design philosophies and guidelines that I'm sharing are all in this code. I really want people who are looking to do more engineering than just plug and play. There's a lot of value in plug and play. I think Mark Bates has built an amazing framework called Buffalo. Early on in my Go career, I used BGO, which is heavily used in China. These are amazing frameworks, and they will get you up and running in a very, very productive way, and they work really well. But I didn't want to build another framework. I wanted to build what I call a starter kit. If you wanted to learn how to make beer, you would go get a starter kit, and would have you do 3 or 4 things. And then you'd get a starter kit that would make you do 10 or 12 things. This is what I'd love to see more of in the Go ecosystem. Starter kits. Some that do a little bit more, some that do a little bit less, but give you the opportunity to do the engineering that you need to do within the constraints that you have. I think that's what we've built here. And I've already started to share with you today some of the design philosophies and guidelines that we have in this code base. So love for everybody to kind of look at this, contribute to it. And I'd love to hear your design philosophies and guidelines on building all this stuff. There is a massive amount of stuff you need to learn. So you must have your design philosophies and guidelines in place. Your teams need to, so those PRs that you're code reviewing are consistent day in and day out. And here's a good base of that if you're looking to start building something new. All right, my time is up. So thank everybody for coming out this early in the morning.